Is the screen visible?
Yes, sir.
Yes, sir.
Okay, so we are discussing about POSIX threads, and so in this class mainly I'll be showing those codes. We'll run those codes and see that how that clone works, how to execute the top command, and how to interpret the output of the top. So all those what we have discussed in our last few classes. We'll basically execute that, and finally I'll run one uh, code using pthread library, and the type of the thread will be attachable thread because by default it is attachable like this. And you will also see that how we can change the thread feature to detachable. Okay, so let us consider the code.
Sir, I had one question from the previous class.
Yeah.
Sir, if we don't call pthread join, so after let's say one child thread has terminated, will that turn into some kind of zombie thread, like zombie processes were there? Is zombie thread also a possibility?
Well, I am not aware of any zombie thread kind of thing. That I have to check because zombie thread, this term I have not ever encountered. So if I have not, I mean, I have created it as if it is a attachable thread, but I am no longer interested in uh, synchronizing with that. Whether it ends up with zombie thread, that I have to check. I'm not sure.
Okay, sir.
Yeah, you can also check, but yeah, I have to check and confirm. I don't think it will be a problem because you see it's a part of the process itself. So when till the point the process continues, it will be there. So because threads are executable instances, independent executable instances within a particular process. So if the process terminates, then anyway they will be all removed or discarded. But in case of process, it was a different thing. Like if the child process terminates, and the parent also, but the parent is running, so it has got a different kind of dependency. So definitely some trace will be there for the parent thread to synchronize with it. So if it is not executing, or if before execution of say pthread join, the parent thread gets stuck in some other statement, say for example it gets suspended because of some other reasons. So any child thread that terminates uh, in the thread control block, because the details of the thread execution, its state, then other thread related information like process control block, that need to be stored right in the thread data structure that is maintained within a process. Now as in Linux we mentioned that instead of process it is better known as a task. So there is a task structure, and within the task structure it should have information related to, or it should have pointers to the threads or the thread control block like that. So definitely that will remain till the parent tries to synchronize, and if the parent, it is not by mistake, but even if there is a pthread join statement, but the parent before it reaches there it gets stuck somewhere else, so the TCP should hold that information in anticipation that the parent should join with it. Now whether we call it as a zombie, that I don't know. Your point is if the parent thread terminates meanwhile, right?
Yes, sir.
Yes, if the parent thread terminates, I think you can write a small piece of code to check what happens. I mean, how it works. So
Okay, sir.
uh, just we wrote it in case of parent child. So you create a, let a parent thread be created, it creates two child threads, and you intentionally make it attachable mode, it is by default. Then you ask the parent to terminate, the parent terminates, parent thread terminates. So the what does it mean, what do you mean by the parent thread terminates here? So the parent thread terminate means the original process gets terminated. So do you think the child threads will retain?
No, sir.
So that is not possible at all. Now the other question is, if I allow the parent to continue, but the the parent misses the pthread join, okay, and the child thread executes and it exits. So in that case, you can check what is there. So you start the child process, let it sleep for 5 units of time, and let it exit. But the parent thread goes into maybe an infinite loop without calling join, and see the status in the mm, in that using that ps minus elf.
Okay, sir.
So that way you can check whether the status is changed, or is there any change in the status. Okay, so if I so let us start with the first example, that of the clone VM. I think you all can recall. So let me increase the where it, I think it is visible, right? The screen, can you see?
Yes, sir.
Yes.
Hmm. So you see there is a hash defined GNU source and all this. These are typical inclusions that you have to make. And then this is the main library file. I mean, sorry, header file that you have to include to deal with. Sorry, this one. So I'm sorry, I'm not talking about pthread. So these are the normal ones that we use for calling malloc or this clone and all this. So here what we do, we call here clone. Do something is the function. This is the do something, the details, and here we allocate the stack and we pass the base address of the stack with the size. And then clone VM means I would like to create an executable instance with the common virtual memory same as that of the parent thread, and both the parent and child will display their PIDs, and then afterwards it will free and it will get in the infinite loop. So if I run that code, okay, there is some warnings we can ignore for the time being. Okay, so as we wrote the code, both will be in an infinite loop. So the both the parent thread and the child thread is running. So now here if we check, so this is what we found, that in this particular case the 334 will be the original process threads PID, the original parent threads PID, and its LWP ID also will be the same. That means the original process is assumed to have a single thread of execution when it was created, and because of that the thread identifier or the LWP lightweight process identifier will be the same. And then when it creates a child thread, that child thread will have a different ID. So it will be so this is something equivalent, creating a as if a new process is created. So in some sense this is not as lightweight as that of a thread, because you see a separate process ID has been there, and so it treats the new executable as if it's a new process, because it has got a distinct process ID 335, and that new process will have a single thread of execution. Okay, so although it is it's a lightweight process, but the thing is this is in not sense it is the lightweight, but from the display we can say that every process in Linux corresponds to at least a lightweight process. And what the scheduler schedules, the scheduler schedules these lightweight processes. So these lightweight process IDs are scheduled by the scheduler. Okay, so these are the executable or scheduling entities, scheduling units. Okay, so this is this part is done. Then we come to the variant of clone, which looks more much similar to that of the understanding of thread that we have. So here again the same header files, and if we focus on this clone system call, as we mentioned, the only change is instead of in addition to clone VM, we have here clone thread and clone SIG-hand. Okay, so this will ensure that the new executable entity will not be created with a separate PID, rather it will have the same PID as that of the parent thread, but it will have its own LWP ID or lightweight process ID, or you can say thread ID. Okay, that is expected. And as usual we have allocated the space, the size of the stack, and the function name is child function, which is the details of which is written here. Doesn't matter whatever is written here, but so this is what it is.
So
And
clone sig and clone thread, these are some kind of objects.
no, these are not objects, but these are options, and if you basically combine these options to make the request of how you are going to create that entity. So these are options. So you can say that these are say so this corresponds to some numeric value.
Okay. And we are ordering them all together.
Yeah, you are ordering them. So once we order them, that means we know that what options are there. I mean, so what will be the final request?
Okay.
Okay, and then so I think this is again a very trivial one. If we run that, so this will be, so it is still running because they are put into an infinite loop. This again shows the warning, which you can ignore at this moment. Then if we run it, okay, I think vmthread.c. What is this? Parent ID is this. What's wrong in it? Okay, so if I one, so now again there are two, there is a child thread created, but now the child thread will have the same PID as that of the parent thread. That is what we wanted, but still it will come up with a different LPW ID or thread ID. Okay, if I run here the top command, so I think you can see this top command. So this is the total number of tasks, the processes, and top actually lists the processes with respect to the unique IDs that they have got. So these are the 7 processes. One of them is running, that is the top itself, and 6 are sleeping. Okay, this is also sleeping because of the case that the parent thread I have forced it to sleep for 1000 units of time. Okay, so that's why it is showing as sleeping. If I change it to for, finite for loop, if I press Q, so if you can see that the top is running, and if I press Q, it will exit. Okay, then again if I check the PS using the PS command, still the same, and then if I press stop, so you see the top is running, it keeps running, and so with a certain periodicity, see the values are changing. So in periodic intervals it will refresh the values based on the, so it keeps running till you press a Q, till you press the Q key. So it's just like a monitor which monitors the different utilization of the CPU, the memory, and how the different processes are functioning, what is their percentage utilization, everything. And in fact, so this output of the top, whatever it displays, can be directed to a text file. Okay, so what you can do in your original code here, if you want that, you are running some applications, but you are interested in noting some performance parameters, and accordingly you would like to change your decisions, so you can run the top command. Any command can be run using the system. So are you aware of the system function call? Hello, anybody who has used the system function call?
No,
Are
sir.
you there? Can you hear me?
Yes, sir.
So any of you have used the system function call?
No, sir.
So if you type here system function call in Linux, or example, see what system does. Can you see this? The system is a function call where you can pass a command. Any command if you pass, it will be executed. You see that the system pause, it will pause it. If you type here ls or ps, it will be executed accordingly. So if we write here system, then top, where it is, okay, let it be here.
Sir, what are the arguments in main function?
Where? Here.
Yes, sir.
Yeah, I have not passed anything, so it will not consider that. So this is command line arguments. If I have command line arguments, I can. So for that we generally do this. Otherwise we make it void. Although I have mentioned it, but I have not passed it, and neither have used it in my code. It is just for. Uh, so I can simply write it as void. It's of no use here. Command line arguments, I have not used it here. Have you used command line arguments earlier?
Yes, sir, I have used.
Yes. So it is something like when I run this, I can show it later on in some example. Say I am running dot slash a dot out. Now this is the name of the executable, say for example. So this means that is in the current directory. Now here maybe that a dot out is a small program, a utility to add the numbers, the values that you pass while executing the statement, right? So if I write a dot out, then 2, then 6, then 8, then 9, and press enter, so that case it will extract. So this, so what you are doing is 2365 2689. This you are passing as arguments in the command line. So this is called the command line. So in the command line you are passing these arguments, which who will receive it in that case?
So those parameters.
These parameters will receive it. So if you want to make that, if you want to have that provision that when I run a executable file, some application in the command line or in the shell, so I would also like to pass some additional arguments. Say what we do in case of say for example copy. So copy the source file to the destination file. So you give the file names there. Okay, then say chmod you give something, so that is the argument to the command. So in our own applications, in our own executable also, instead of just writing the name of the command, if we want we can pass additional arguments, and that is basically a variable list of arguments. So as you can see here, I can pass sometimes 2, 3, 8 and 9, 4 arguments. It will add it and return. I mean, if I write an application like that, or if I write here these two, it will add only these two and it will return the value. So the thing is, it's a variable list of arguments that you pass. So how many arguments you have passed, if you have made this, so that will be stored in argc. Okay, so it's a count of the arguments that you have passed. And this argv, so what kind of argument it is? What is the type of the argument?
Sir, an array of strings or
array of strings. So array of strings. So the thing is, in this case, this first argument will be treated as a string. That means it will be storing the character 2 followed by the null character. The second argument will be treated as a string. So 6 followed by the null character. So instead of doing this, I could have written say subrata, then nandi, and then say G8 304, like this. So that means this application will receive 3 arguments: the first name, the second name, and the quarter number, like that. Okay. So in case of numeric also, when I write here 2356, these also are accepted as strings. So these are the first. So it's an array of strings, as you found. So the first element of that array of strings is 23. The second element is 56, like that. Got the point? And so once it is a array of strings, so if you would like to use 23 as a integer, you have to convert that string to integer. Okay, so how you do that? argv0. argv0 actually holds 23 in this case, thus in string version. Okay, and argv1 will store 56 as a string. So it is the ASCII of 5, the ASCII of 6, and the ASCII of null character, like that. and you have to convert it back to integer, and then you can add. But first of all, so generally in such codes, what you do here, the first line should be using a for loop. You write here for I equals to say 1 to how many arguments you have passed?
argc.
Argc, because argc actually counts number of arguments. It may be 2, it may be 5, it may be 10, it may be 50, I don't know. So for I equals to 0 to I less than argc I plus plus, then you write so that many number of times I would like to extract. So whenever you executed that, the actual arguments that you have passed is actually stored in the array of strings which is pointed by argv. So argv will store the first, argv1 is like that. So you have to basically write argv I, the ith string you would like to extract. Now if you know that it is a actually an integer, you should convert it. So atos and all those, you can write your own function also to extract it and to do that. Okay, but so in this case we are not doing any such thing, so I can simply ignore it. Okay, so here if I write here system, the one that we were talking about, and if I write here say ls, then see what happens.
Sir, spelling mistake.
Spelling mistake. Oh, system. So can you see what is appearing in the screen?
Yes, sir.
What happens? So what it does, what is the purpose of the system function call?
So executes the command which is specified
Yeah,
inside of it.
just executes the command that is there. So if I write here top, what happens? So the point is, if you want to run a command from your program, you can do that. You don't have to manually type it. You can place it and it will be executed. Now if I type here top, and then if I, it's still continuing, is it, and then can you see it's running top? Okay, and if I press q, then that part appears. Is that okay?
Yes, sir.
Yes, sir.
Now so what I mean to say is, if you say you wrote a particular code where it has got a parent thread and it has got several child threads. Now you would like to or it may be it may not be top, it may be something else also, like ps minus elf. This is also possible.
So can we ask to execute any executable file over there? Like,
Yes, anything can, it's possible, anything is possible.
okay.
Hello. So now the thing is, uh, so from this, if I ask you that instead of calling get pid, you'd can you process this, information and get the pids that is created, I mean the pid of the parent process and pid of the child thread process. Is that possible? Are you getting my point? I know it has been executed, but instead of writing here get PID to get the parent process ID, instead of doing that, I would like to get it from this from the information itself. How can I do this? Got my question?
Yes, sir.
Yes, sir.
How to do it? Text. index.txt.
Sir, when you are executing the program, the first statement is the system statement, no sir?
First statement?
The first statement it will execute is the system statement, no sir? So by that time, the child threads are not created. So how it is showing us the PID and all the status of the parent thread and child threads?
Which one? Just a minute. Here.
Yes, sir. The PS
Now, did it
PS
show?
command.
Did it show the child thread information? What is
No,
this?
sir.
Error out is 404 is the original parent process, and what is this 405? What is this 405? 405
PSELF.
corresponds to the process corresponding to the execution of PS-ELF.
Yes, sir.
So the actual child thread has not yet been created here. If you look into this, if you would like to see that, you have to execute it here. If I do the same thing, then it will work. But it gets stuck, it never goes to this level.
So you have put one infinite loop, sir, I think. Okay, that's after.
Okay, I mean okay. So now you see, now these two are created. This one is showing. Is it fine?
Yes, sir.
Yes, sir.
Okay, but what I wanted to show, I don't know why it is not working, is redirecting. So this is what I want. You see, I give a command, then I press this one. So the standard output stream will be redirected to the file only. It will not be visible in the terminal. Okay, so this is what it means. That means what we are when we are running some commands. So this is the command. If I redirect it to this file, so it will not appear in the output, rather it will be dumped in that file. Now if I open that file using cat, I can see the contents, or if I want, I can process it also for extracting some information. Are you getting the point?
Yes, sir.
Yes,
Is
sir.
that clear? So you see there are few options. So if you do this, so or if you want to append the data, append means so you are running, maybe say you are running PS minus ELF before creating the clone. before creating the thread, right? And after creating that, also again you are trying to execute. So you'll get the next execution output to be appended in the to the appended after the previous one. Okay, so this is for this case. So why it is not working, let me check. So it would have worked here also. Say ps elf yes, it worked. Cat x.txt. What will you find here?
So
What so instead of, so the idea is, instead of getting this displayed here, what to display? Getting this content displayed here, I am trying to redirect it to another file which will be saved. So the entire output becomes it just gets saved, and I can check the output. So this is out. Okay. Now it is as simple as that, processing of a simple text file. So I can write a small piece of code to parse it and find out what is there. So I know that this is a PID. So I'll first parse. So if it is Python, it becomes extremely simple to extract the information. If it is in C, you have to do a little bit of coding to do this, right? But you can get all those details, like how many NWPs has been created. So in fact, you can, so by extracting the information, you can have a summary report kind of thing, and you can do it for top also. This top also you can do the top command. Oh, so because it keeps running, and if I press Q, it dumps. So now let us see. Can you see this?
Yes, sir.
So now if I come back to this piece of code, and if I run here, so this is, say, top y.txt. So now let us run. Q, then it exits. Now if I cat y.txt, I get this information, right? So what I
Yes.
mean to say, once I have done this, now I know that by this time this is executed. So now the problem is I have to press a Q there. So it will be done, but you have to press a Q in the in your terminal, so that it takes the dump and it proceeds. Okay, otherwise it will get stuck. So here, if you write a few lines of code here to process this file, because you can know how to parse it and all, because you know the entire syntax, everything is known. I mean, entire format. So here, if I want, I can know that what this is doing and all this, or I can probably check the other one, like cat x.text, and so that this also is changed.
So that was y.txt.
y dot y.txt is also, no, I mean, see, this may not have that LWP information here. So if I want, I can dump the output of PS, and from that I can. So my question was, instead of using get PID directly, can I still extract the PID information of the parent process thread
Yes, sir. From the text file, we
from
can
the text you
process
can?
it.
So again, I mean, whether we require it or not, that's a different thing. But this is, but if I want to find out the CPU utilization, so what we can do here, say it is, say for example, PS underscore ELF. So now you know this CPU utilization is all 0 here, right? Because CPU, this is all 0. I mean, I can make use of the information here to change the scheduling, to do something with the threads, to make their performance better or to optimize the performance. That is my point. Okay. So based on some resource utilization information, I can think that what way I have to set the attribute of the newly created thread, or maybe a running thread, I would like to change the attribute maybe. So those things can be done in runtime. Whenever you want, you just run that system function with PS or with top or some kind of commands through which you can monitor the resource utilization. You dump it in a file, extract it, and then make changes. And I mean, in the so it dynamically in the program itself it changes and all this. Is that part clear?
Sir, why should we press Q even after redirecting the?
No, but see, redirection is whatever it appears in your screen gets redirected. But does it stop the execution of the top? The top will stop, will exit only if you press a Q. That's all. So redirection means whatever it appears in your screen gets dumped in a file. That's all. But it does not stop the top.
Sir, it means by using system keyword
Hello?
we can run the commands in background, right?
Yes. Hello.
By using system keyword we can run the commands in background.
Yes, that is also possible. So it is just like it's a system call through which you can run commands, but you can run it in the background. That is also possible. Okay. So yeah, we probably deviated from what we are discussing. So the thing is that we just now discussed about uh, is how to use this argvrc, and how to use a system command which will and through which we can redirect the output of a executable command in a file. It can be done in the through the shell also, or it can be done through my program also, and if I want I can then process here the output. So all these are possible, right? Okay. So this is about the okay, one more. So once again we just run it, and we'll see one more thing. What happened? What changes I made? Oh, system is there, no? Should comment. I would like to enable the infinite for loop. See something in the top command. I would like to have the utilization of all the logical CPUs, logical processors, that I want to see. So these are all running. Now in the other terminal that I have got, executing top here. So now I would like to see the details of the CPUs, not just the combined utilization. I would like to see the breakup, the individual utilization of the CPUs. What should I press?
So top one.
So it's just top is already there, so I just press 1. That's all. Can you see? If I press 1, it will appear in details. If I again press 1, it will be in this mode. So it will toggle between these two modes. Is that part clear to others? Okay. And if you basically add them up, you see CPU 0, 1, 2, 3, the utilization, if you add them up, this is the mean. So It's the mean values that it gives. So these are all the mean values, and logical CPU wise information is here. So that is what I meant. So if you make this option, then if you want, you can get this display, and you can dump it in a file, process it, and find out what is happening.
Yes, sir.
You can find out. So this is a very trivial example, but there can be some applications which you run, where you run multiple such threads based on the maybe client request. So these threads or this application may not be a standalone application. It may have, as I mentioned, in case of a web browser, forget about web browser, you have got a like file server kind of thing. Okay, so file server, say if I have got a file server application that I've designed in my own machine, this local machine, and I would like to have I would like that my file server application should accept request from some remote clients. Remote client means you in your machine, if it is connected in the LAN, you will run a client code like which will request a file from my server, like the file that I have got in my machine. So whenever there is a, so anybody can ask for a particular file. Now the first thing is, whenever there is a request, new request comes, so that can be done. So whenever there is a request coming from another machine, so whenever two processes like that client process and this process wants to communicate across multiple physical machines, we need socket programming. So that we will learn in your network class. So that is also very simple. You can use TCP sockets, UDP sockets. So that is simple. So that's a simple thing. So if you can pass on that request using some sockets, so here you have to, whenever you know there is a request came, you should open a thread. You open a thread, and then that thread will take care of your searching. So you have made some request to a file. So if the file is available, then what you do, maybe or you have got a thread which will receive, which is always listening to new requests. If a request came, you just check whether the file is there or not. If the file is there, then you create another thread which will actually serve the file, because the entire file need to be transferred chunk by chunk to the client, right? And once it is done, it will be off. Now in this case, so you can write a simple file server, or I mean file manager, uh, network enabled file manager code like this, a client part and the, now the thing is, maybe the client, after it has received say half of it or 70% of it, what happens? It terminates, or the network connection drops suddenly. Again it gets connected, again it requests. So what you can do, you can make a log here, you can maintain a log where whenever a client requests a file, it will check that how much it has been already copied there, so it can keep a track of it. So whenever you again connect it, it will copy the rest of the file contents from that point onwards where it stopped. Okay, so in this way we can, so the point is, you can have a network application, a file server kind of application, where the searching and delivery of the file is done in the server part, maybe in a host machine, and there can be many such clients which run some other piece of code which makes the request. If it is there, they will receive it, and even if the connection breaks, it will not restart, it will resume from the point where it stopped. Now in such cases, what you may see that maybe that some clients are so you can check the utilization of I mean how much time or how much CPU and all these individual threads are utilizing, and you can decide that I should stop this thread, or I should change the priority of the thread. That you can do. Okay, so I can write some application, and based on this information I can tune those applications, their performance and all this. uh, is that part clear, what I am discussing?
Yes, sir.
Well, so these are some ways of how to manage the whole thing. So let's come to the other case. So here, so this was the example where we have used the pthread library. Okay, so this is a pthread library. You see, in that case, we don't have to create the clone. We don't have to call the clone system call, and also it is much smarter. We just have the pthread.h. So this is the library function. Sorry, the header file to call pthread library functions. So here in this pthread library, we'll have again the same thing. So this is a pthread create. So pthread create is there. So this is, so what do you think internally what it actually calls?
So clone, sir.
Yes. Internally it calls, by the time we know that it actually calls a clone system call in case of Linux, right? But in maybe in Windows it will have something equivalent to clone that will enable the same facility. But in case of Linux or Unix based systems, clone is enough. But clone with all those options like clone VM, then clone threads, along with clone cgand. That is does. Okay. So you know the internally that it does, and it makes use of the nptel library, and nptel library uh, actually considers a clone system call. And once the clone system call is used, although this pthread create is a user level library, user level function, okay, this is not a system call. So pthread create is not a system call. These are pthread.h is basically a header file. So this is a user level library, but this user level library by calling clone, it creates threads which are, or lightweight processes which are recognizable and maintained by the kernel, Linux kernel. Okay. So now once you have done that, instead of having the original parent process thread, it will probably have in this case 20 more threads created. Okay, and these all the threads are schedulable by the kernel scheduler.
Yes, sir.
And we can make use of this, we know that the scheduling is such that it makes sure that it uniformly scatters the load and all this. So this is possible. And there is a lot of analogy between the you see between the clone system call as well as this pthread create, excepting that the creation of the stack and pointing to the stack, all these are taken care of by this pthread create. So you really don't have to bother about that how much is. So there's a default stack size, but if you want, you can increase or decrease the stack size. So stack size is also manageable, but you don't have to explicitly create the space for the stack and pass it here. So that way it is safe. So you basically view it from a higher level, abstract level, right?
So can we call this pthread create an wrapper function?
Yes, it is some kind of wrapper. It's some kind of wrapper, but the more important thing is it's a standard. So the standard means the interface. So what will be the arguments, what exactly will be the arguments, and what will be the order of the arguments, that is important. So pthread actually, this POSIX thread is an interface definition. So it defines this interface. Okay. So it
Yes, sir.
defines the interface, and the internal implementation of that interface, it varies from one system to other. Is that clear? And
Yes, sir.
while wrapping it, or while providing a interface by wrapping the internal details, it hides many. So the stack, the notion of the stack is completely hidden. You don't have any idea of where the stack is, because you don't need to. There's a default stack that is provided to you. If you want to change its size, you can do that, but otherwise you should not be bothered about creating a stack and pushing its address and all this. All those are relieved. Okay.
Yes, sir.
So here, what important thing is this thread's I. What is this thread's I? So this is the thread ID. So this thread ID we can uh, we can see and we can display it also. So thread so this is a thread ID that is created, and this null is corresponding to the attributes corresponding to the new thread that is going to be created. Thread code is basically the function. So this thread code actually appeared as the first argument in clone, but you know that this actual function should be there. It is inevitable. So once it takes the address of the function while calling clone, it will pass it as a first argument. So it knows how to do it internally. And then thread arguments also, it was there and it is here also. Okay, so we have the provision here to pass the arguments. So that is what this wrapper enables you. And so this is pthread join. So this you can see that I think I have explained in details of what the argument so what exactly is the uh, type of the argument. Here it is, this is asterisk asterisk. So that's why you see uh, no sorry, this is asterisk void asterisk, so that's why you are passing the address of it. This is the thread underscore t, which is equivalent to pid underscore t, and you have declared an array of two such things. So this part is clear, I guess. And then once it and in fact I have not executed any pthread exit here, but I'm trying to join to it. So pthread join, I write here pthread join where I specify the thread id, and this is null. So null means I ignore whatever it is returned here. So if I display, I can display it here itself. Let's see how this code works.
Sir, you need to increase the size of the pthread.
Array out of bound. You have
Which
created
one?
only.
Okay, this is how many I mentioned? 20. So let it be 100.
Sir,
And this,
arguments, thread arguments also.
which one? Thread arguments. Okay.
Yes, sir.
Okay. This also, how I pass 20 arguments. 20. Hopefully it is correct. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So its name is class test pthread example. Warning, warning.
Sir, for threads of it is
Oh,
long
sorry, sorry. So
unsigned
no. So you have
unsigned.
to see. You have to link like the math, like the math library. You have to link this pthread library. Can you see this? Hyphen L pthread means you are linking the pthread library. You are linking it. Hyphen L. That's the option. Okay.
Sir, linking it means
it works. Hello.
So why did we need to link it?
Huh?
Sir, we had already provided the pthread.h no sir in
No,
the
you have to link it. I mean, these are some linkable libraries. So these are linked optionally. There are some linkable libraries. So if you link it, only then it will be considered during the execution. This is optional. That's why you have to specify -l pthread. So there are many such. So that is there you include, but here during compilation you have to link it so that it gets compiled and it gets linked to it. So here if I uh, so can you see the LPW? So how many? Okay.
Sir, why are the thread IDs very huge?
No, those are logical IDs. These are not same as that of the LWP IDs. These are not LWP IDs. So that is why I wanted to show you this one by displaying it explicitly. So these thread IDs that is obtained through this pthread library is not same as that of the uh, that LWP IDs, but they are so they are mapped to something different. So this pthread create this wrapper function, the details. So they manage it in a different way. They provide a different ID. You can see it's a logical ID given to each individual LWPs. Okay, so these two are not the same. The values are not the same. So now here you see 496 is basically the 496 is the original PID of the parent thread process, and its LWP ID also is 496. But then it has created all the remaining 20 threads where the PID is the same, but their LWP IDs are different, 97, 98, 99, 100 like this. And you see the utilization that what we wanted to. So another thing is how, so this number of in NLWP, what is this? What it represents?
number of lightweight process.
Number of lightweight process corresponding to what? Corresponding to a particular PID.
Yes.
What is the PID here? 496. How many NLWPs? By
20.
default, one PID is associated with one LWP. But if you create more using this particular option of using pthread create or using a specific option of clone, now you have got too many. So it is basically 20 plus the original one is 21. Is that fine?
Yes, sir.
Yes, sir.
And each of these are 21 because this corresponds to the PID that it has got. Okay, so okay.
Sir, what's the difference between LWP and thread ID?
Now LWP and thread ID, which thread ID in that pthread create?
The values displayed the prompt.
Just a minute, why it is not coming? Wacom is not working. What's the problem? Just a minute. Wacom is not working. Anyway, I cannot show it here. Let me just. So the Wacom is not working. Anyway. So yes, what is your question regarding these IDs?
Yes, sir. Difference between these IDs and
Difference, as
LWP.
I mentioned. So these LWPs are mapped to some values here. I don't know what the internal logic is of mapping those, but it is mapped to some different IDs, which is distinct enough. You see, no two threads are actually having a same thread ID. So this thread ID is basically a ID that is assigned by the pthread create library in the user space. So this is in the user space, they are identified with these unique IDs, but internal to the kernel identifies them with respect to these IDs, LWP IDs. Okay, so this association of LWP ID with the pthread ID is maintained in the user level library, user space. Okay. Hello.
Yes, sir.
Yes, sir.
So pthread library is not a part of the kernel. So it is a user level library which makes use of kernel system calls to have this threads created, synchronization of the threads and thread related operations. That is, so those thread operations are defined and implemented using that NPTL, uh, NPTL standard. Following that, something will be there definitely. So like that. So every operating system designer must come up, so which is NPTL compatible, should have some APIs through which can be used to implement the POSIX compliant thread functions. And once it is done, if you write an application, it is portable anywhere across like all other OS which supports this POSIX standard. Okay. So okay, so now if I type here top, if I press 1, can you see the CPU utilization? All of them, earlier it was only 30%. In the previous example, it was 30%. Why it was 30%? Hello?
Sir, we didn't have infinite loop.
So actually there are using the considering the parent thread, then the child thread, and then maybe the top itself. So 3 processes were running. I mean 3 LWPs were running basically, which were actively running. And now you have got so many of them. So there are so many that the scheduler, after it schedules, on an average each CPU receives, as I mentioned, discussed in the last class, each of the CPU receives a pool of, say, on an average 5 LWPs to execute, and because of this they are almost full. You see, they are almost full, 91, 98, 99, 99, like that. So the small bit of difference, that is not exactly 100, is because of the switching across LWPs, you can say. Switching
Context
across,
switching.
it's a context switching. Now to be more specific, it's context switching across among the LWPs, because those are the executable units, right? Like that. And when we discussed the PCB that was in the Morris Buck book, you will never find an entry corresponding to these LWPs or these threads and all this, because as I mentioned, that book was written based on the classical design of the operating system, Unix operating system, when there was no Linux, there was no concepts of threads. So you cannot map this understanding or this LWP and all this to that particular book. For that you have to have the new books on Linux kernel, which will have these details. But then it is not completely different. But again, to make this provision happen, there should be so the kernel from kernel version 2.5 or 6 onwards, uh, some additions and some modifications has been done. Okay, and okay, now let us am I audible?
Yes, sir.
Yes, sir.
Shows bad quality anyway. Good. Now this is another program using threads. Again, it is the same. I'm just showing it. So as you can see here, that this is the p thread underscore t. We have created these number of threads. It's an array. It's an array. You can hold thread IDs. These are thread arguments, and in this case, the arguments are basically the value for the ith thread. It will pass I. Is a that is for the first thread it will pass 1, the second thread it will pass 2, like this. Okay, and the result code is there. And then here in a for loop I am trying to create the threads, p thread create. Again, it is a by default, it is a attachable type of thread. I have used assert. I think assert I have explained in your in some of the classes during C++. I'm not sure if I have done it last time. So assert means if it fails, it will simply exit. It will make sure that if it is not result code, if it is non-null, only then it will proceed. If it is non-null, it will immediately abort at this point. Okay.
Yes,
So
sir.
any error condition can be checked using assert, and accordingly you can abort, or you can, if it is correct, you can proceed otherwise. Okay.
Yes, sir.
So here uh, we have the pthread code, uh, the thread function, and here what I am trying is I am generating a random value in the range of number of threads. So if I have got 20 threads, I will have a value generated from 1 to 20 at random, and I will sleep for that. So some threads will uh, sleep for more time and less time, like that. Okay. So this is not a very meaningful code, but this I just try to exhibit the different features of thread creation. And this is where I would like to join through the threads. The thread join. So let me see how many threads are there. Number of threads. What is the number of threads?
So 20.
So if I run here, what is that name of the function? Thread example 1. Not run because it should create. Okay. So at least I can get rid of those warnings that I got while creating threads using clone and all, right? So once I have done that, if I run it, how many threads I created?
So all of them I saw number 20.
Huh?
Oh, so 20 seconds.
I'm going to know it is 20. thread example 1. Where is that? This is 20. Okay, I fixed it here. Okay, that's why it's creating 20 threads. And these are all the 20 threads. OP again the same. Press 1. Still the utilization is the same. Okay, and so this part is done. Now, why we consider lightweight threads? What is the performance benefit of using lightweight threads?
So
What is the
much,
major it is much faster.
Yes.
So I hope if I create, say, how many threads? So 1 lakh threads. If I would like to create, if I create 1 lakh threads, I do something and then I exit, or maybe creation, simple creation also. So if I create, if I call fork 1 lakh times, and if I call pthread create 1 lakh times, which one do you think should be much faster?
pthread create.
So can we can we see this? I mean, can you write a small piece of code to see this? This is really happening in terms of milliseconds, or maybe in the order of milliseconds. What to do? You know how to create threads, so call pre-thread, and you basically plug in. You basically call the system clock. Okay, you call the system clock, and you call the system clock before calling pthread create, and after calling pthread after pthread create has created all the 1 lakh threads or processes, you again call it and see the difference on the time. Is that fine?
Yes, sir.
So just make this experiment and see how much is the difference. Is there any difference or not? You see that. If the difference is not visible, then increase the number even maybe 2 lakhs or maybe 5 lakhs and see the difference. So they should have some say visible difference. হ্যাঁ সুজয় আমি ক্লাসে আছি, পরে কথা বলছি। ও আজকে মিটিং ছিল না, দাঁড়াও আমি 5 মিনিট লাগবে আমার, আমি ক্লাসে আছি। হ্যাঁ মিটিং ভুলে গেছি আমি একদম। ওকে, so I think you can write that code, right?
Yes, sir.
So try this. So what I meant, and another thing is all the codes where to find the prime number or searching and all this, which I did or which you basically solved using or calling multiple processes, child processes, can those be repeated using this multi-threading concept?
Yes, sir.
Yes, sir.
So I'll publish the assignments, the next set of assignments, but this will be all the repetition of that. Whatever you have, whatever you did using, say, I think the last one that I gave. So just try to repeat it using multi-threading. That's all. Okay, so logic is the same. Just you try to organize it using the pthread create concept. Okay, I've got a meeting. I have to end it, but before I do so, let me just let me check this. Okay, this one.
Sir, we have a class from 4, sir, DVMS.
From 4.
Yes, sir.
Yes, I too have a meeting, so just 1 minute. I'll take just 1 minute time. So can you see the chapter 12 in the rocks beginning in Linux programming book?
Yes, sir.
Can you see this, the book name?
Yes,
I have
sir.
already shared it with you. So I just request you to check this POSIX threads chapter, and that POSIX thread chapter you will have just focus on this part. Ignore this one because these are not yet taught. See, can you see this part? Setting detachable state attributes. So that I just mentioned. This one, state attributes. It is in this is in page number 512. Okay, chapter 12. Can you all see?
Yes, sir.
This will be an
Yes, sir.
assignment. So you have to create a detachable thread also. How to do that? You see, this is the pthread attribute init. So there is a function which actually initializes. Init means initializes pthread attribute object. So this is how it is done. And in fact, you can set it to attachable. You can get the state and then change it. Set the scheduling policy. Okay, then there are many other, set the stack size. That is important. So we are not basically dealing with the stack size when we are accepting the default, but if you want, you can increase the or set a stack size, and that will be done automatically by the pthread wrapper. Get that, you can get the stack size. What is the stack size? If you want, you can increase it also uh, for your applications. So there is a whole lot of uh, functions through which you can set the different features of that pthread attribute object. Is that okay? That is named as pthread attr underscore attr. So this detachable thread. So how you do this? There is a small example given here. Okay, so I'll just end it here. So pthread attribute. So you see pthread attribute. So if you mention this macro pthread create detached, so it will be set to detachable mode. And after setting this, so you basically, so what you do, you basically create a thread attribute object, and then you call this function to set its attribute to detachable mode, and then you call pthread create. Okay, and if you call pthread create after that, here is pthread create, and here you can see that in the second argument it is not null. It is passing the base, it is passing the address of that attribute which you have set. Is that okay?
Yes, sir.
So now automatically this thread becomes a detachable thread. It will act as a detachable thread. Now you can do one thing. You can make all the odd number threads at attachable and even number threads at detachable. You can. So I'll give that assignment so that you can try both of it. And at least whenever a thread is created, you can get the get its stack size, the attribute, this state size, and all this. You can always get it. Okay. So these things you can try of your own. I'll try to publish the assignments by today. Okay, anything else?